Hello students, today's agenda is to check homework. We'll be learning about the recursive rules, and today you will be able to do page 11. The objective is to write a recursive rule from an exponential function. And so in here, we need to identify different parts of an exponential function. The exponential function, it's a function that you can use with any terms. For example, in here, if I want to know the year 10, I can just replace 10 in here and I will know how much I will have. This is my initial point. Or what I start with. This is the base. And you will also have a cycle in here. When there is nothing, that means that there is one. We don't pay attention to it in this lesson, but just so that you know, okay? So for example, in here is every month, every 1 month. If it was every, like over 4, every 4 months or something like that. And an example could be like you start sending 3 emails and then they multiply by 5 every 1 month, for example. Or if it was 4, every 4 months, something like that. So now they want us to change it to a recursive rule. A recursive rule is something that you will need to know the previous one. You're going to separate it as f of 0. It's going to be the first, what you start with. In the present, right? This represents month 0. How much do you have? Oh, you start with 3 emails. And then the rule is f of n equals, you're going to have your base on here, f of n minus 1, meaning multiply that by the previous number. Here you would have the base, which is 5. Okay, so basically your recursive rule will always look like this. F of 0 equals, and whatever your initial point is going to be right there. F of n equals whatever the base times f of n minus 1. That is always going to be the same for all of them. Here you put the initial point, which is this one right here, and here is the base. And for number 2, it means that you start with 1/7 of something. It multiplies by 9 every single time, or every month, every year. We don't know what that represents. So it's going to be f of 0 equals, the initial point is 1/7. F of n equals your base, which is 9, times f of n minus 1. You can put a times in here or just leave it like without it. For number 3, f of 0, what is the initial point? 0.75. So this is not difficult, it's just understanding what to place where and what is always part of that recursive rule or recursive formula. In here is 1/3, that's the base, times f of n minus 1. F of n minus 1, it just means multiply by the previous one. So let me show you what that means in the first one. You don't need to do this for our assignment, but just so that you understand. So the first number in a table, and that's going to connect to the next 2 as well, n and f of n. So n, let's start with 0, then 1, 2, 3. Again, this part you don't have to do it, it's just to understand it. So for f of 0, you just have 3. Then for f of 1, we're going to find it. F of 1 is equals to 5 multiplied by f of n minus 1. N is 1 minus 1. I should replace that n by the one that I'm looking for. So it's going to be 5 times, right? This means times. F of 1 minus 1 is 0. And what is f of 0? Well, 5 times, we go to f of 0. F of 0 is equivalent to 3, and it just means multiply 5 times the previous one, right? When you're looking for 1, we look at the previous one, which is 0, f of 0. And so it's going to be 15. If we were looking for another one, the second one is f of 2 equals, the rule in here is f of 2 equals 5 times f of 2, we're replacing all the n's by 2, minus 1, and that's 5 times f of 2 minus 1 is 1. It just means multiply 5 times f of 1. So to look for f of 2, I multiply 5 times f of 1. And what is an f of 1? It's 15. Whoops, that's that part. And bring down the 5. 5 times 15, that's 75. And so once you get this, it just means that you're multiplying by 5, multiplying by 5, multiply by 5. So for 3 and 4, all you have to do is just multiply by 5 once you see that pattern, okay, that you're multiplying by 5. And so 75 times 5 is 375 times 5 is 1,875. So that's the recursive formula. The recursive formula, it means look at the previous one, right? Look at the previous one and multiply it by 5. Okay, for the next one, it's number 4. They don't give you an exponential function, they give you a table. And the first part is easy to find because it's f of 0 is just that value right there. So in here, f of 0 is equals to 100. For f of n equals f of n minus 1, go from the last one and then divide by that. And that will give you the number that you need to put in here. So 8100 divided by 2700 equals 3. And you can look at it dividing the last one by the previous to last, or you can just see, what's going on? 100 to get to 300, oh, I multiply by 3. And from 300 to 900, oh, I multiply by 3. Oh, I multiply by 3. So that's my base. Now, sometimes it's not going to be as easy, but then you can look at all the ones that are whole numbers. And so f of 0, that's my initial point. We're going to get 500. F of n equals, remember it's f of n minus 1, meaning to get to any number, I need to look at the previous one and multiply by whatever we put in here. How can we find that number? We said divide the previous one. I'm not going to look at that one, but divide this by that. Because it's division of a small number divided by a bigger number, what I can do is put it as a fraction, 4 divided by 20, and then simplify to get the fraction that I need in here. In here, I divide, both are divisible by 4, divisible by 4, so the answer is 4 divided by 4 is 1, 20 divided by 4 is 5, so that means that my base is 1/5. 500. Remember that we multiply by the numerator and divide by the denominator. 500 times 1 is 500. Divided by 5, 100. 100 times 1 is 100. Divided by 5, 20. 20 times 1, 20. Divided by 5 is 4. So yeah, we're multiplying by 1/5 to get from here to here. To get from here to here, multiply by 1/5. And so that's going to be my base. That's the recursive rule. With this, we end our lesson. If you can please support our channel by giving us a thumbs up, subscribing around here. This is the next lesson. Here you will find the entire unit. Now you're able to do page 11 and have fun.